Hi everyone, my name is Damen. I am a PhD student working with Dr. Christine Toe at the University of Nebraska at Omaha. The focus of this very brief presentation is on how designers structure information to support idea generation. Design information comes from many places and in many forms, such as end goals, user requirements, and technological capabilities. Throughout the design process, designers rely on this information to inspire them and to guide design decisions. To do so effectively, designers must develop strategies to manage these various types of information and reduce complexity. For example, they develop numerous retrieval strategies to acquire and recall information. They use readily available information and historical design information to support learning and improving on past designs. As such, meaningfully structured information is an important enabler for design success and innovation. So we know that information organization is important, and we know that people use it, but we don't quite know what they look like because these organizational strategies are cognitive processes. Now, because information structures are so dependent on the project-specific context, it can be difficult to investigate those in real design projects. Therefore, this study sought to make that process of tailoring design cognition to a specific design project more visible by qualitatively investigating how designers would structure information in a more experimental setting. Specifically, our guiding research question is, how are designers' information organization strategies related to the ideas they generate during early phase ideation? We invited 8 local designers with at least 3 years of design experience to attend individual lab sessions. We asked them to generate ideas to an open-ended, hypothetical problem of reducing pedestrian accidents caused by distraction from mobile devices. To investigate their information structuring behavior, we created 16 information sheets, which each contained around 200 words about the problem. We provided the designers with 15 minutes to read these sheets, and then asked them to organize them in a way that made sense to them, using any organizational schemes, annotations, and reasonings that they wanted, while verbalizing and visualizing their thought process using a whiteboard and markers. Lastly, we gave the designers 20 minutes to sketch their conceptual solutions to the problem using pen and paper. No specific directions were provided for how the designers could generate ideas, although the instructions to generate as many ideas as possible are quite typical for a brainstorming technique. So how did our designers' information organization strategies relate to the ideas they generated? In total, our designers generated 74 ideas, which 2 coders independently analyzed using an 18-question design rating survey. Aggregating the survey results into 14 higher-level idea features allowed us to draw relations between these 2 components. To identify these information organization strategies, both authors analyzed the videotapes of the designers organizing the information sheets to understand their thinking process. Our 8 designers utilized 3 different information organization strategies that build up in complexity. It is important to note that no one strategy is better or worse than any other strategy. I will briefly discuss each strategy by showing a schematic representation along with a digital recreation of a participant's organization, as well as the prevalent idea features associated with that strategy. In the first strategy, which we call clusters, the designers are simply categorizing information sheets that belong together into smaller groups of similar sheets. The prevalent idea features are a focus on environment and handheld devices. In the second strategy of relations, designers take the grouping of the clusters and add indications of how these sheets are related to each other within each group. Compared to the clusters, the relation strategy is more aimed towards devices and standalone artifacts. In the third strategy, they extend the relations forming approach by adding a hierarchical component in which information sheets are nested within another information sheet or category. Befitting for the last strategy, the nest strategy incorporates both device and environmental features equally, and focuses both on standalone and handheld devices. Ideas from all three strategies track surroundings, provide visual feedback, and alert pedestrians rather than vehicles. The most obvious limitation of this work stems from our methodological choices. In this study, we prioritize deep insight into one person at one stage of the design process. However, the majority of design work is more collaborative in nature, and it is possible that designers adapt their information structuring behavior according to the stage of the design process that they are in. So future work should look into incorporating both of these aspects. To conclude, the purpose of this study was to better understand how designers interact with various kinds of design information in the early phases of a design process. We asked 8 designers to visualize their strategy of organizing information for a hypothetical design task, and we compared those with the features of their generated ideas. Our 2 main findings are that firstly, designers structured the information in 3 different ways, suggesting that there are similar patterns across designers in the way that they approach information. Secondly, different strategies lean towards different features in their generated ideas, further supporting the importance of the information organization strategies on the design process. Thank you all so much for your time.